Hello, everybody. In this lecture, we will be talking about subatomic particles of an atom with J.J. Thomson's experiment on the discovery of an electron, study of cathode rays. Although the credit for the first atomic theory is usually given to ancient Greeks, a landmark in the progress of chemistry took place with the advent of Dalton's atomic theory. It was for the first time John Dalton in 1808 put forward certain postulates. The main postulate was that matter consists of extremely small, indivisible particles to whom we call as atoms. This concept continued to hold grounds for a number of years from 1808 to 1897 till the research done by various eminent scientists like J.J. Thomson, Goldstein, Rutherford, Chadwick, student of Rutherford, Niels Bohr, and others till the beginning of 20th century, I can say, beyond doubt proved that atom was not the smallest indivisible particle but had a complex structure of its own and was made up of smaller particles like electrons, protons, neutrons, etc. At present, 35 different subatomic particles are known, but the three particles, namely electron, proton, and neutron, are regarded as the fundamental particles. It was 1879 when William Crookes studied the conduction of electron through gases at very low temperatures. For this purpose, what he did, he brought a glass discharge tube measuring approximately about 60 centimeters long, and on the both sides of this glass discharge tube, he inserted two metal plates, as you can see in the figure, the cathode and the anode. Collectively, both the cathode and the anode are called as electrodes. What he did, he applied very high voltage, a potential difference of 10,000 volts to this glass discharge tube. Inside the glass discharge tube there was a gas, and if you see on the upper side of this glass discharge tube, this tube is connected to a vacuum pump, and the pressure inside this discharge tube is being reduced. Pressure of the gas inside is being reduced through this vacuum pump. When the pressure is reduced to as low as 0.01 mm, what William Crookes observed, it was found that some invisible rays are emitted from the cathode. The presence of these rays was detected from the fact that glass wall of the discharge tube opposite to the cathode begins to glow with faint greenish light. Obviously, this must be due to the bombardment of the walls by some rays emitted from the cathode. And Sir J.J. Thomson capitalized on the same concept, and he started working with the same glass discharge tube. He brought a flask, a discharge tube with gas inside it. Even he changed the gas inside it, that we can talk about that in the later part. And he did the same proceedings as was carried by Crookes. He found that he observed that there are some rays which initiate their path, which start their movement from cathode towards anode. What he did later on, he applied electric field, both electric as well as magnetic field to the discharge tube. Magnetic field you will study in your high classes, but about electric, this field you can just see in this diagram. On the upper side, you can see on both the sides positive and the negative charge of the discharge tube. Once he applied electric field, there he saw applied field on both sides. He saw the rays deflecting towards, when they were moving from the cathode towards anode. With the application of the electric field, he saw these rays showing deflection towards, some moving towards this side and some moving towards the positive part. Anything that can be deflected by electric field is a charged something, is a charged species, a charged particle. Or if electric field exerts force on anything, we say that's a charge. So by force, if direction is changed, acceleration is created. And we are aware of the most famous relation: force is directly proportional to mass into acceleration. That means these charged species have a mass and are particles. So one thing is clear, that the stream of these particles, they are charged, they have a mass. Observation number one. And the second observation that was recorded when J.J. Thomson sir made this experiment, it was found that these particles showed independent behavior. When the gas inside the discharge tube was changed, and it didn't change the existence of the rays, it didn't change the behavior of the rays. When hydrogen was, same behavior was shown. When helium was inserted, same behavior was shown. Same kind of electrical discharge was produced despite changing the gas inside. So we conclude that these fundamental particles are nothing but they are electrons. This is how electrons were discovered by Sir J.J. Thomson, and these cathode rays are nothing but electrons. I hope this is clear. See you in my next video with Rutherford's model of an atom.